Alrighty, this is the review for your Algebra 2 first 9 weeks DCA, District Common Assessment. Number 1, solve 5 times absolute value of x plus 6 equals 20. So 5 is trying to get into the absolute value bars, but it is not allowed. So we would have to divide 5 on both sides first, which would leave me with the absolute value of x plus 6 is equal to 4. Now that it's isolated, the absolute value bar, you write the equivalent equations. So you take x plus 6 out of the bar and you equal it to the opposite outcome, so negative 4. And the other equation would be x plus 6 equals 4. Again, when you have an absolute value symbol in your equation, you're usually going to have two solutions. So you got to set up the two equations to get ready for your solutions. So in both equations, I'm going to subtract 6 on both sides. On the first one, x is equal to negative 10. On the second one, x is equal to negative 2. And then check your solutions with the original problem. Okay, so first I'm going to check negative 10. That would be 5 times the absolute value of negative 4, which is 5 times 4. And yes, that equals 20. Now I'm going to check with negative 2. So negative 2 plus 6 is a positive 4. So this is 5 times 4 again. And yes, it checks out. So your solutions are negative 10, negative 2. On number 2, the absolute value bar is already by itself. So I can write my two equivalent equations. So again, the first one is take the contents out of the box, a minus 4, and it's equal to the opposite result. So the opposite result would be a negative 3a plus 6. And then the other version is a minus 4 equals 3a minus 6, exactly as it's written. So you got to have an opposite and the current. Now solve for a in both. So I have negative 3a. I'm going to add to both sides. On my first one to give me 4a minus 4 equals 6. Then I'm going to add 4 to each side to give me 4a equals 10. Divide both sides by 4, so a equals 10 over 4, which reduces to 5 over 2. Let's leave it a fraction. Now, on the other equation, I'm going to subtract a to get negative 4 equals 2a minus 6. Then I'm going to add 6 to both sides to get 2 equals 2a. Then divide both sides by 2. So I would get 1 equals a. Now, again, we must check our work with the original problem. So absolute value equals 3a minus 6. Oops, I forgot to leave room in place of a. All right, so the first one I'm checking is 5 over 2. All right, so 5 over 2 minus 4 is going to give me, I'm going to need a common denominator, so this is 8 over 2. So that would be the absolute value of negative 3 over 2 is equal to 3 times 5 halves is 15 halves. So this would be a positive 3 halves over here. And then in order to combine 15 halves with 6, I would need a common denominator again. So this ends up being 12 halves. So 15 minus 12 is 3 halves. So that one works out. 5 halves does work out. So let's check the other solution, which was 1. Alrighty. So 1 minus 4 is negative 3. 3 times 1 is 3. Absolute value of negative 3 is positive 3. And 3 minus 6 is negative 3. So it doesn't check out. So the only solution to this system is 5 over 2. So you must check your solutions. Some of them don't work. Number 3 says Stephen is looking for an apartment to live in. He has budgeted $450 for this. He's willing to go plus or minus $25 of his budget. This situation is modeled by the equation absolute value of x minus 450 equals 25. Solve for x. So this equation is all ready to go. I just need to write the two equivalent forms. So that means x minus 450 equals the opposite outcome, so negative 25, and x minus 450 equals the outcome we see, 25. So in the first equation on the left, I'm going to add 450 to both sides. I would actually do it on the other one as well, so let's do it at the same time. So the first solution I would receive is x equals 425. And the second solution I would get is x equals 475. And again, check your solutions. So 425 was the first one. 425 minus 450 is negative 25. The absolute value of negative 25 is positive 25. Oops, too many 25s. So this checks out. This is a solution. Now we're checking 475. So 475 minus 450 is 25. The absolute value of 25 is 25. So both solutions check out. So the solution to this system is 425 and 475. I'm introducing this new way of showing your system just in case. You never know what could be on the DCA. So be prepared. But for me, just circling both of them is plenty. But just in case you see something that looks fancy like this, you're prepared. Number 4, the average weight of a bag of Doritos chips is 1.8 ounces. Most of the bags are within 0.2 ounces of this. If the equation x minus the absolute value of x minus 1.8 is equal to 0.2 represents the situation, find x. So again, it's already ready to go and set up my equivalent situations. So the first one would be x minus 1.8 equals the opposite. So negative 0.2. The other equation is exactly as it is, just without the absolute value. Okay, in both cases, again, I'm going to add 1.8 to both sides. On the first one, you would get x is equal to 1.6. On the second case, you would get x is equal to 2.0. And then check your solutions. So 1.6 is first. 1.6 minus 1.8 is negative 0.2. The absolute value of negative 0.2 is positive 0.2. So this solution does check out. Now let's try 2.0. 2.0 minus 1.8 is 0.2. The absolute value of 0.2 is 0.2. So this solution also checks out. So the solutions to this equation are 1.6 and 2.0. Number 5 says find f to the negative 1. Remember, that's f inverse. If f of x equals 8x minus 2. So the first step in this process is change f of x to y. So y equals 8x minus 2. The second step is apply the definition of an inverse. The definition of the inverse says you switch x and y. So x becomes y becomes x, everything else stays in place. So equals 8 and then the minus 2. Now you have to get y by itself. First, Add 2 to both sides. So x plus 2 equals 8y. Then divide everything by 8. So you would have x over 8 plus 1/4 equals y. X over 8 is the same thing as saying 1 over 8x. So just be prepared for any and everything. Last but not least, since this represents the inverse, now we must put it back in function notation. So you would say 1 over 8x plus 1 over 4 is equal to f inverse of x. And you can switch it around if you wanted. You could put f inverse of x is equal to 1 over 8x plus 1/4. But that's what you do. For number 6, it would like for us to graph f inverse of x. Okay. Well, let's create a table. So our first table is x, and this would be f of x equals 3x plus 6. So I'm going to pick a negative x, a positive x, and or a 0 and a positive x. All right, and let's substitute it in. So 3, let me just set it up for all of them. So -1, 0, 1. Alrighty, 3 times -1 is -3, plus 6 is positive 3. 3 times 0 is 0. 0 plus 6 is 6. 3 times 1 is 3, plus 6 is 9. So the ordered pairs would be -1, 3, 0, 6, and 1, 9. Now, on our inverse, we know the definition of the inverse means switch x and y. So this was x, this was y originally. So that means on my inverse function, I expect to see 3, -1, 6, 0, and 9, 1. And then you would graph it. Let's also write the equation so we can put it into our calculator to demonstrate that this was done correctly. So again, like before, you change f of x to y. Then x and y changes positions. And then isolate y. So subtract 6, divide by 3. So I know I did that fast, but these are some things that should just roll off your tongue and come fast for you as well. So now I have these two equations. Let's graph them in our calculators and demonstrate why these work as they do. So I already have an equation in here. So f of x was 3x plus 6. F inverse of x is 1/3 x minus 2. So the blue will be my original function, the red will be my inverse function. So let's graph them. All right, now let's look at the tables and see that it matches ours. Focus on the blue right now. So when x was -1, y was 3, just like we calculated. When x was 0, y was 6. When x was 1, y was 9. That's exactly how we calculated it. So now let's look at when x is 3 and look at the red column. So find x of 3. And when we look at the red column, it's -1. So the red column is our inverse column. So that point is correctly there. Good. Now let's look at x is 6. When x is 6, y is 0 in the red column. Good. And lastly, let's look at when x was 9. When x was 9, y was 1 in the red column. So that's how the inverse is graphed correctly. So again, you can graph all you need to do is graph the original function. So make a table of about 3 good points, and then just switch the x and the y values in your second table, and then graph those new 3 points. And that's pretty much it to graphing a function and its inverse. So let's take a pause right here and resume back in just a moment.